So welcome to this class on Fourier series. Today we will be learning about the inverse Fourier transform and how to calculate it and how to go back to the original transform using the inverse Fourier transform. We'll be doing a few examples, so stay tuned. The Fourier transform of a real valued function fx is given by integral minus infinity to infinity fx e raised to I ux dx. You denote it by f of fx or f cap u. So f inverse of f cap u will be 1 by 2 pi integral minus infinity to infinity f of u e raised to minus I ux dx. And f of u is integral minus infinity to infinity fx e raised to iu dx is called the complex Fourier transform. So the inverse Fourier transform is 1 by 2 pi integral minus infinity to infinity fu e raised to minus iux dx. So if f of cu equal to integral 0 to infinity fx cos ux dx, this is the Fourier cosine transform, then the inverse transform will be 2 by pi integral 0 to infinity f of cu cos ux dx. Again, if f of su is integral 0 to infinity fx sin ux dx, this is the Fourier sine transform, then the inverse transform will be 2 by pi integral 0 to infinity fsu sin ux dx. So basically we'll be using this rule. That is, if f of u is integral minus infinity to infinity fx e raised to iux dx, then fx will be 1 by 2 pi integral minus infinity to infinity f of u e raised to minus iux dx. Alternatively, if f of u is 1 by root 2 pi integral minus infinity to infinity fx e raised to iux dx, then fx will be 1 by root 2 pi integral minus infinity to infinity f of u e raised to minus iux dx. So we have the 1 by root 2 pi here. Again, you have the Fourier cosine transform. That is, if f of cu is square root of 2 by pi integral 0 to infinity fx cos ux dx, then fx will be root 2 by pi integral 0 to infinity f of cu cos ux dx. And again, there is one more point to remember. If fsu is root 2 by pi integral 0 to infinity fx sin ux dx, this is the Fourier sine transform, then the inverse transform will be root 2 by pi integral 0 to infinity fsu sin ux dx. So coming to a few problems, find the complex Fourier transform of fx equal to 1 when mod x is less than or equal to a, equal to 0 for mod x greater than a. Hence evaluate integral 0 to infinity sin x by x squared dx. Now f of u is integral minus infinity to infinity fx e raised to iux dx. That is integral minus a to a, because otherwise it is 0, 1 e raised to iux dx. So that will be e raised to iux by iu within the limits minus a to a, because integral of e raised to x is e raised to x. So this is 1 by iu e raised to iua minus e raised to minus iua. We are substituting the limits here. Now cos e raised to iua is cos au plus I sin au, and e raised to minus iua is cos au minus I sin au. So simplifying, we get f of u as 2 sin au by u. Now we have to go back. So the inverse transform will be fx is 1 by 2 pi integral minus infinity to infinity f of u e raised to minus iux dx. This is what we saw. So in this case, fx will be 1 by 2 pi integral minus infinity to infinity 2 sin au by u e raised to minus iux dx in this problem. So this is, the 2 gets cancelled. You get integral minus infinity to infinity sin au by u e raised to minus iux dx. Now if I put x equal to 0, fx will be 1, because coming back to our original definition, here when x equal to 0, fx will be 1. So you get 1 equal to 1 by pi integral minus infinity to infinity sin au by u du, and this will be sin au by u is even, because sin is odd and u is odd, so you get an even function. So this becomes 2 by pi integral 0 to infinity sin au by u du. We're using the fact that integral minus a to a fx dx is twice integral 0 to a fx dx if f is even. So integral 0 to a sine au by u du will be pi by 2 when you take this to the other side. If I put a equal to 1, we get integral 0 to infinity sine u by u du is pi by 2, or integral 0 to infinity sine x by x dx is pi by 2. Coming to the next question, find the Fourier transform of fx equal to mod x when mod x less than or equal to alpha, equal to 0 when mod x greater than alpha, alpha is a constant. So we have seen that the Fourier transform is integral minus infinity to infinity fx e raised to iux dx. That will be integral minus alpha to alpha. It will be x e raised to iux dx. So that will be, you can take it as when you integrate by parts. So you will get it as x e raised to, the order is right, a and e. So x e raised to iux by iu within the limits minus alpha to alpha, minus integral minus alpha to alpha, derivative of x is 1, e raised to iux by iu dx. So we are making use of the fact that mod x is x here, we are taking the positive value. And this will give you 1 by iu e raised, substituting you get alpha e raised to iu alpha plus alpha e raised to minus iu alpha minus 1 by iu e raised to iux by iu within the limits minus alpha to alpha. So this is alpha by iu e raised to iu alpha plus e raised to minus iu alpha. This becomes minus 1 by I squared u squared e raised to iu alpha minus e raised to minus iu alpha. So this is alpha by iu. This becomes e raised to iu alpha, and you get it as plus e raised to minus iu alpha. I squared is minus 1, so you get plus 1 by u squared e raised to iu alpha minus e raised to minus iu alpha. Now e raised to iu alpha is cos u alpha plus I sin u alpha. E raised to minus iu alpha is cos u alpha minus I sin u alpha. So substituting here, you will get alpha by iu 2 cos u alpha plus 1 by u squared 2I sin u alpha. So we have learned how to calculate the Fourier transform and also how to calculate the inverse Fourier transform. So stay tuned and thank you.